I woke up last week asking myself, what did I even learn this week? Hey guys, welcome back to Nate's Learning Nuggets. So this week I'm looking at a lighting specific aspect of things that I learned and was working with this past week, dealing with color correction. Now this is going to get a little bit on the geeky nerdy side for a lot of you, and that's okay. But what I was dealing with was an issue of trying to get cameras to see light color properly. So when you have a white, does it actually look like white, for example, on camera? But the challenge with that as well is I also want to make sure that it looks as close to that way as possible to the naked eye as well, or eye with glasses on, depending on who you are, like me. So what the challenge with this is that no camera lens is nearly as good as an eye is. There's myriad of factors of that. Short version is we can't make things as good as God can, so we roll with the best we can on that. So what happens is in order to get it correct, you need to tell the camera what color temperature is white. This temperature is measured in degrees Kelvin, which is used in the scientific world a lot, but basically what it is a measurement of what temperature does that wavelength of light translate to. And then what I'm trying to do is get everything to match together as well as possible. So I need to set the temperature of that, but then I also needed to go through and try to get all of my lights to match to that as close as possible. Very difficult to do when you're working with a mixture of tungsten lights and different types of LED fixtures and all of that. So I did two things. One was I gathered all of the information and the data that I could about all of the fixtures I was working with. So I knew exactly, okay, from the manufacturer of this particular light, this is the color temperature that it emits for this particular color selection, wavelength, whatever. So I gathered all of that information, and then I still needed to get all of my color temperatures to match correctly. Well, what I had been doing before was I got my color good previously. The issue was I was losing so much brightness from my lights because I was basically putting a filter in front of every single fixture that it just caused everything to look extremely blue and very dark. And I needed to fix that without hurting my color response of everything on camera and without making things look terrible in person at the same time. So I was looking along, and one thing that's done to look at this is you take all of your color temperatures, and those equate to what's known as a mirrored value. I won't get into what all that stands for and everything, but it's an acronym. And I basically take the number 1 million, divide it by my color temperature in Kelvin. So if I have a color temperature of 2800, for example, I take 1 million and divide that by 2800, and that number that results is my mirrored value. So then what I do is I look and see, okay, I've got all of these lights and they equate to these different mirrored value numbers. Perfect. Now I need to get all of those values to be as close to each other as humanly possible. I then went and looked at different color gels, and I found out that the issue I was dealing with before was I had a mixture of gels that brought the temperature to where I wanted it to be, closely with mirrored value, but I was stacking a lot of gels together. And by stacking them all together, I was cutting my light transmission through those gels and filters down to 30% of their transmission capacity. Well, by cutting that out and using the correct gel that didn't require a lot of stacking of gels, I'm still cutting down on transmission, but not nearly as much. I'm closer to that 60% range instead of 30% range, which really helps significantly. Yes, I'm still cutting out some light with that filter in place, but I'm doing a lot better than I was before. Also, it doesn't translate through as blue because I'm not tripling up on everything accordingly. So what I did was I took my value, so I said I've got this fixture that's putting off we'll say 6,500 Kelvin. Okay, so that equates to my mirrored value. And then I want to target everything to average, but then I have these other fixtures that are sitting at 3,000 Kelvin, so that's their mean value. Well, I need to find somewhere in the middle for all of those to meet. So instead of bringing the 3,000 all the way up to the 6,400 like I was trying to do before, I went ahead and found a number in the middle. In my case, that's 5,100, and brought my 3,000 up to that 5,100 value using a gel, and then in bringing the 6,400 down to that 5,100 level using a combination of light color selections on my LED fixtures and using some gels that actually bring the temperature down. So there's two types of gels I was working with. One is called a CTB, color temperature blue, and the other one is a CTO, color temperature orange. And basically what each one is doing is polar opposites of bringing my mirrored value up or down accordingly, or warming up the light versus cooling it off. In that sense is what's happening. So I went ahead and did that, and honestly I'm pretty happy with the finished product. One of these days I'll show you some pictures of how that all turned out. I set a 3/4 CTB gel on my 3,000 Kelvin lights, and that brought my value up to really close to that 5,100 mark. And then I went and white balanced all of my cameras to all of that, and they were spot on exactly where they needed to be. So it pays. Sometimes doing the research and putting the numbers into things, calculating everything out first, really makes all the difference in the world. Sometimes it seems like a waste of time. I assure you, if you're really focused on what you're trying to get done with it, it won't be. So that's what I've got this week on Nate's Learning Nuggets. Hopefully that was interesting to you, as I know it helped me learn a lot this past week as we help make things even better for cameras and in person, which is very important. Thanks, guys. Have a great day.